Hello everyone, welcome back to my YouTube channel. Today we are going to look into the topic implementation of Boolean expression using CMOS. But firstly, let us start with the basic definition of a CMOS. CMOS stands for complementary metal oxide semiconductor. It utilizes both P-type and N-type MOSFETs. It is basically a combination of PMOS and NMOS semiconductors. This is used for low power consumption and to achieve few other required outputs. Now let us go with how a PMOS and an NMOS looks like. This is how a PMOS and NMOS look like. A PMOS has a circle at the gate terminal where an NMOS doesn't have, and the source, gate, drain terminals look like this. PMOS and NMOS. This is how a basic PMOS and NMOS implementation should look like. And after that, now let us dive into the basic design rules for a Boolean expression. These are the rules. For a PMOS, a dot symbol represents parallel and a plus symbol represents series. For an NMOS, these are quite different, as plus represents parallel and dot represents series. Let us understand the implementation with a simple example. As we all are good with the rules, now let us implement this with an example. Design a CMOS NAND gate. Basically, a NAND gate expression is output y is equal to a dot b whole bar, and the truth table for this is as follows. If both the inputs are high, the output is low. In remaining all other cases, the output is high. This is how a truth table of NAND gate looks like. Now let us go with the implementation of NAND gate. Here a dot b, for PMOS, a dot represents both the terminals should be parallel, so we did a and b a parallel combination. And then for a series, and for an NMOS, dot represents series, so we took a and b in series combination. So a and b, both p types are in parallel, and then a and b, both n types are in series. Now we took the output in between them, so this output is y is equal to a dot b whole bar. This is how an implementation of NAND gates look like. Now, as we all are familiar with an example, let us implement it with an example. Design and implement the expression f is equal to a dot b plus c whole bar. Here a dot b, here the dot for a PMOS represents, what does it represents? For a PMOS, a dot represents parallel, so we need to draw a PMOS, a basic PMOS. These both need to be parallel, so we draw them parallel first. This is a source terminal, this is A and this is B. Here A and B are implemented. Now this is in plus with C. This means these both should be in series with the CMOS. So we take a basic C here in a parallel combination. This is how an output look like. This is how should an output look like. For a PMOS, this is the circuit diagram. Let us implement this expression for an NMOS. Now NMOS, this is A and then this is B. A and B are in series. Now this must be in parallel with C, as we have plus for an NMOS. A plus represents a parallel combination, so we take C here. This is VDD. Sorry guys, this is VDD and this is VSS. And this is how a design of this particular expression must look like for a CMOS. Firstly, we took A and B, both are in parallel, and then we attached it with a C which is in series. This is the implementation for P, and then we combine it with N. Here A and B are included with a dot symbol, so this means they need to be in series, and then in parallel with the C. So we drawn A and B in series, and then we took C, and then the output is taken across this particular terminal. This is how an design implementation of this particular expression looks. Thank you guys. Do like, share and subscribe if you like the content.